Ray began the new year the same way he has spent much of the past several months, under the night sky, tracking 3I Atlas as it continues its rapid exit through the solar system. He went live shortly after midnight and remained on stream for hours, capturing as much usable data as conditions would allow. Over the course of the night, from roughly 12 a.m. until about 4:30 a.m., he recorded an extensive imaging session, collecting close to 177 individual exposures of the comet before atmospheric conditions and geometry finally forced him to stop. Earlier in the evening, between about 10 p.m. and midnight, the comet was already rising in the eastern sky. Ray explained that during that window, the data quality was compromised. The object was still low on the horizon, and light pollution combined with atmospheric turbulence made the images appear soft and blurred. The comet was visible, but the finer structures were difficult to resolve. As the night progressed and the comet climbed higher, the situation improved noticeably. After midnight, the background darkened, the air steadied, and the signal from the comet sharpened. With each passing hour, the images became clearer, revealing details that were simply not accessible earlier in the night. Once the raw frames were cleaned, aligned, and processed, Ray began to notice something familiar but still unsettling. The comet's tail, including the sunward pointing antitail, remained conspicuously long. This was not a new observation. It was something he and other observers had been seeing for weeks. But seeing it again, night after night, as the comet faded and moved farther from the sun, reinforced the sense that this structure was not transient or accidental. Ray referenced a recent paper by Avi Loeb, who analyzed a series of Hubble Space Telescope images taken across multiple dates. That analysis highlighted structured jets emerging from the nucleus and an antitail extending far beyond what standard comet models would predict. Importantly, the structure did not appear briefly and vanish. It persisted across months, through perihelion, through dramatic changes in solar heating, and through countless rotations of the nucleus. Ray pointed out that his own ground-based images showed the same general morphology. This was not an artifact of one telescope, one night, or one processing technique. He then brought up an image captured roughly a week earlier, not from the most recent session, but one that now carried new weight. In that frame, the antitail extended far into space, longer than it had any right to be if it were simply a short-lived dust feature. Ray had shown this image live previously, but in the context of Loeb's calculations, it now appeared as corroborating evidence rather than a curiosity. The structure was there before. It was still there now. Despite the persistence of the tail, Ray noted that the comet itself is clearly changing. The central condensation appears smaller and dimmer than it did several weeks ago. The overall brightness has dropped, consistent with the object receding from the sun and exhausting its most volatile materials. Yet even as the nucleus shrinks in apparent size and luminosity, the tail structure refuses to disappear. That contrast, fading core, enduring jet, is one of the most intriguing aspects of 3I Atlas. During the live session, Ray noticed something subtle but intriguing. In several frames, the jet appeared to show a slight curvature or arc. At first, this raised immediate questions. Was this a real physical feature, perhaps caused by rotation, precession, or changes in outgassing direction? Or was it simply noise, a product of low signal levels as the comet dims? After cleaning the data and reducing noise, the curvature became less obvious, but it did not vanish entirely. It appeared intermittently, suggesting either a weak but real structure near the limits of detection, or a marginal artifact amplified by processing. To investigate further, Ray performed comet-aligned stacking. In this technique, the comet's nucleus is held fixed in each frame, while background stars are allowed to trail. This removes the distraction of stellar motion and makes it easier to see subtle changes intrinsic to the comet itself. When the aligned sequence played back, the nucleus remained stationary, but faint variations in the jet became more apparent. In several consecutive frames, a narrow extension appeared, slightly curved, then weakened, then reappeared again. Ray was careful not to overinterpret the result, repeatedly cautioning that low signal-to-noise conditions can play tricks on the eye. Still, the repetition across frames suggested that what was being seen was not a single random fluctuation. As the session continued, Ray emphasized that time is running out. 3I Atlas is fading quickly. Based on its current brightness trend, he estimated that within about a month, the comet may become little more than a faint point, even for powerful amateur systems. This makes the timing particularly important because the object is racing toward Jupiter. While it will not collide with the planet, its trajectory brings it close enough to make the approach scientifically interesting. Ray demonstrated this visually using orbital simulations. He showed the comet's current position relative to Jupiter, then advanced the clock forward by 1 month. In that short interval, the comet covers an enormous distance, closing the gap dramatically. The visualization makes the speed unmistakable. 3I Atlas is not drifting leisurely through the solar system. It is tearing through it. He contrasted this motion with human spaceflight. A spacecraft sent to Mars typically takes 6 months or more to arrive. Jupiter, far more distant, requires years, yet this interstellar object crosses comparable interplanetary distances in mere weeks. The comparison is not meant to suggest propulsion, but to emphasize scale. The velocities involved are staggering, and they underline just how different interstellar objects are from the bodies we are accustomed to studying. Returning to the imagery, Ray highlighted a specific frame where the antitail stretches far beyond the inner coma. This was the image that crystallized the issue for him. The tail remains narrow, coherent, and extended rather than fanning out and dissipating as most comet tails do. According to standard models, such behavior requires either unusually large dust grains, an atypical ejection geometry, or a sustained mechanism that continues to feed the structure over time. The final images from the night showed the comet still clearly present, though undeniably dimmer than before. In some frames, the jet appeared to fade and reappear, hinting at modulation tied to rotation or changing illumination. Ray reiterated that as brightness drops, separating real features from noise becomes increasingly difficult. Nevertheless, the fact that similar structures appear repeatedly across independent frames argues that at least some of what is being seen is real. By the end of the presentation, Ray made it clear that while 3I Atlas is fading from view, it has not finished telling its story. The long-lived antitail, the structured outgassing, the rapid motion toward Jupiter, and the persistence of these features across time all suggest that this object is not a simple, one-note comet. Whether future analysis ultimately places it within the bounds of exotic but natural cometary physics, or points towards something more unusual, the data gathered now will shape that answer. Ray closed the session by thanking viewers for joining the live stream, encouraging subscriptions and notifications for future updates, and noting that channel members would receive access to additional processed images and data. As 3 Atlas slips farther into the dark, each remaining observation becomes more valuable. The comet may soon be too faint to follow, but the questions it has raised will linger long after the last usable frame is captured.